Now let's begin our questions part. In the first question we have, does limit x as approaches to 3, the absolute value x minus 3 over x minus 3 exist? So we should look its left hand and right hand limits. So let's begin. If this absolute value x minus 3, okay, if this is greater than 0, which means x is greater than 3, okay, then this absolute value x minus 3 is equal to x minus 3, right? Which means when I draw my number line, let's say 3 is here, so x is greater than 3, right? So we get closer to 3 from the right side. So for our right hand limit, we can say that our right hand limit is equal to limit as x approaches to 3 from the right. Okay, so this absolute value goes out as x minus 3 over, we have here x minus 3, so this is equal to, as you can see, this is equal to 1. Okay, so now let's look at the left hand limit. So when x minus 3 is less than 0 or x is less than 0, which means we get closer to 3 from the left side, so then this absolute value goes out as minus x minus 3. Okay, so limit as x approaches 3 from the left side, sorry, this is minus sign, from the left side, so this will become, this absolute value becomes minus x minus 3 over, we have here x minus 3, so this will cancel out each other and we have here minus 1. So as you can see, the left hand and right hand limit, they are not equal to each other. That's why limit does not exist. Let's continue with our second question. Here we have limit as x approaches to minus infinity, square root of x squared plus 2x minus square root of x squared minus 2x. So when you see roots, usually try to solve by multiplying and dividing by its conjugate. Okay, so let's do that. So here we have limit as x approaches to minus infinity. So we will write this one, square root of x squared plus 2x minus square root of x squared minus 2x. Okay, so times, I multiply by its conjugate, which is equal to square root of x squared plus 2x plus square root of x squared minus 2x. Okay, and over its conjugate, it is square root of x squared plus 2x plus square root of x squared minus 2x. Okay, so in the numerator, as you can see, we have the difference of squares. What was the formula for that? A minus b times a plus b is equal to a squared minus b squared, right? So here this is our a and this is our b. As you can see, a minus b times a plus b. So I can write this denominator as a squared minus b squared. So let's do that. So here we have limit as x approaches to minus infinity. So it is x squared plus 2x, okay, minus x squared minus 2x, right? Because this expression, there are a and b value. So it's over, here we have this is in this root, we can write this as x squared, we can take this x squared parenthesis and we can write this as 1 plus 2x, so I will write 2 over x, because when you multiply these two together you will get 2x, plus also same thing we apply here, so x squared in the parentheses it is 1 minus 2 over x. Yes. Okay. Now here, limit as x approaches to infinity. Now let's see what we have in the numerator. So this is x squared plus plus 2x minus x squared plus 2x, right? Because this minus will make this x squared minus and this one plus. So also let me write here. So it's minus x squared plus 2x. So this minus x squared and this x squared, they will cancel out each other, and from here we will get only plus 2x here. They're equal to 4x over. Now here this x squared, it goes out as an absolute value of x, okay, and then we have square root of 1 plus 2 over x, this one, and then plus this one, this x squared also, it goes out as absolute value of x, and then square root of 1 minus 2 over x. Okay, so this is our denominator. Now here limit as x approaches to negative infinity. So since x is approaching to negative infinity, it means that this absolute value x, this is actually equal to negative x. This is also equal to negative x, okay, because x approaches to minus infinity, okay. So our limit as x approaches to minus infinity, so here we have 4x over, so it is minus x square root of 1 plus 2 over x minus x, this is also equal to minus x, so it's minus x square root of 1 minus 2 over x, okay. So here we can cancel out these x's, okay, and then from here 2 over x, when x approaches to infinity, this is equal to 0, and also this is equal to 0, and from here we will get 4 in the denominator, we have 4, and here we have 1, it's minus 1, also here we have minus 1, so minus 1, it's equal to minus 2, so 4 over minus 2, which is equal to minus 2, and this is the answer for our question. In this question we have f of x is equal to 3x squared plus 1 when x is less than or equal to 1, and f of x is equal to 6x minus a when x is greater than 1. So if limit as x approaches to 1 f of x exists, what is the value of limit as x approaches to 3 f of x? So to find this limit, let's see, as x approaches to 3, right? So which one we need? We need this function, right? 6x minus a. So in order to find its value, we need to find the value of a. So how we can find this? We know that limit as x approaches to 1 f of x exists, which means it is left hand and right hand limit are equal to each other. So let's use that. So limit as x approaches to 1 from the right side. Okay, so from the right side, which means x is greater than 1, right? So we use this function 6x minus a. So this is equal to, when I put 1 instead of x, this is equal to 6 minus a, right? And limit as x approaches to 1 from the left side. So now we use this function, which is equal to 3x squared plus 1. So I put 1 instead of x here. So it is 3 times 1, 3 plus 1, it's equal to 4. Now I know that these two, they are equal to each other. So here we have 6 minus a, which is equal to 4. So from here, a is equal to 2. Now I know the value of a. Now I can easily find the value of this limit. So let's do that. Limit as x approaches to 3. so it's f of x, which is 6x minus a, so it's 6x. I know a is equal to 2, it's minus 2, so here we just put the value of x, which is 3 here, so it's 6 times 3 minus 2, and it is 18 minus 2, which is equal to 16. Let's continue with our fourth question. Here we have limit as x approaches to 0, sine 5x minus sine 3x over sine x. So when I put 0 instead of x, here we have sine 0 minus sine 0, which is equal to 0, and also I have in the denominator I have also sine 0, and this is also equal to 0. So I have the indeterminate form of 0 over 0, right? So what we can do here? So in the numerator, as you can see, we have sine 5x minus sine 3x. For this expression, we can use this trigonometric identity, which is sine x minus sine y. This is equal to 2 times sine x minus y over 2 times cosine x plus y over 2. Right? So we learned this from our trigonometry lesson. So for this expression, I can use this equation. So let's do that. Here our x is equal to 5x and our y is equal to 3x. So limit as x approaches to 0, okay, it's 2 times sine. So here we have 5x minus 3x over 2 times cosine 5x plus 3x over 2, okay, and over sine x. Now let's continue. So here we have limit as x approaches to 0. So here we have 2 times 5x minus 3x, it is 2x, 2x over 2, it's 2x over 2, it's equal to x. So here we have 2 times sine x times, here we have 5x plus 3x, it's 8x over 2, it's 4x. So it's cosine 4x over, here we have sine x. So as you can see, these sine x, they cancel out each other. And from here we have limit as x approaches to 0. So we have here 2 times cosine 4x, okay, so this is equal to, I can write this 2 in front of this limit, so it is 2 times limit as x approaches to 0 cosine 4x, and when I put 0 instead of x here, this is 4 times 0, so this is equal to cosine 0, and cosine 0 is equal to 1, right? So it's 2 times 1, and this is equal to 2. In this question, we have limit as x approaches to 0, x times cosecant x times secant x. So let's remember what was the cosecant x. This is equal to 1 over sine x, right? And secant x is equal to 1 over cosine x. So when I put 0 instead of x here, this is 0 times 1 over sine x. So when I put 0 here, sine 0 is equal to 0. So 1 over 0, it's equal to infinity. Okay, so this is equal to infinity. And here cosine x, cosine 0 is equal to 1 over 1. But still we have this 0 times infinity indeterminate form. So what should we do with this kind of indeterminate form? We should rewrite them as fractions, okay? So let's do that. Here we have limit as x approaches to 0. So here we have x, it stays as it is, and over 1 over, we have here 1 over sine x times 1 over cosine x. Okay, I can write this as like this, and from here, so limit as x approaches to 0. So this denominator Actually, this is equal to 1 over sine x times cosine x, right? So this is also equal to sine x times cosine x, right? So I can write this as x over sine x times cosine x, okay? Now here, when you see this sine x times cosine x, you should remember trigonometric identities. And for this one especially, you should remember sine 2x. Sine 2x, this is equal to 2 times sine x times cosine x, right? So from here, we know that sine x times cosine x is equal to sine 2x over 2, right? So let's use this one. So our limit as x approaches to 0, so we have x here, x over, and instead of sine x times cosine x, we write this one, which is sine 2x over 2, okay? So this is equal to limit as x approaches to 0. So I put this to the numerator. So it's 2x over sine 2x. Now let's put 0 instead of x. So here we have 2 times 0, it's equal to 0. Sine 2x, it's sine 0, which is equal to 0. As you can see, now we have 0 over 0 indeterminate form. So when we have this indeterminate form and we have sine function in our fraction, we have one rule. Remember, we have x's here and they are equal to each other, they're same. So we take the ratio of their coefficients, okay? So in this case, we have 2 and 2, which is equal to 2 over 2, and this is all equal to 1. So in this kind of questions, don't forget this rule. This is very useful. Now in this question, we have this ABC right triangle and limit as x approaches to 0, area of ABC over 2x is asked. So let's look at this triangle. So we have here 6 and we have here 3x angle, and to find its area, we know that area of ABC is equal to the length of AB times 6 over 2, right? So but when I look at this triangle, I see that when I look at this angle, actually tangent 3x, this is equal to, let's say this, okay, this is AB length. What was the tangent? Tangent is the opposite side over adjacent side, right? So here its opposite side is the length of AB, okay, over adjacent side, it's equal to 6. So instead of the length of AB, actually I can write this as tangent 3x times 6, right? So let's do that. So here, instead of AB, I can write tangent 3x times 6, okay? So let's go back to our question. So limit as x approaches to 0. So area ABC, I write this one. It is 6 times tangent 3x times 6 over 2, okay? And we also have here over 2x. So this is over 2x, okay? Now this is equal to limit as x approaches to 0. So 6 times 6, it's equal to 36 times tangent 3x over, I can put this to the denominator, which will make here 4x, okay? So from here we will get limit as x approaches to 0. So here we have 36 times tangent 3x over 4 times x. So here this part is equal to 9, right? As you can see here, we have tangent 3x over x. we will use the same formula, which is we take the ratio of their coefficients, right? So here it's x and x we have, and the ratio of their coefficients are equal to 3 over 1, and that is equal to 3, right? So this is equal to 3. So the answer for our limit here is equal to 9 times 3, which is equal to 27. In this question we have limit as x approaches to p over 2 from the right side, sine 4x over cosine x times cosine 2x. So here when I put this p over 2 instead of x, so in the numerator we have it's equal to 0 over, in the denominator cosine 90 it's equal to 0, and times cosine this is p, which is equal to minus 1, but this is equal to 0 over 0 indeterminate form, right? So what we can do here, in the numerator we have sine 4x. So instead of sine 4x, I can write this as 2 times sine 2x times cosine 2x, right? So let's do that. Limit as x approaches to p over 2 from the right side. So here we have 2 times sine 2x times cosine 2x, okay, over cosine x times cosine 2x. So here this cosine 2x, they cancel out each other, and here we have limit as x approaches to p over 2 from the right side. So in the numerator we have 2 times sine 2x over cosine x. Now we will apply the same rule again, because still we are having that indeterminate form. So let's do that. Here this instead of this sine 2x, I will rewrite the same rule again. So limit as x approaches to p over 2 from the right side. So it is 2 times, this is this 2, and then it's 2 times sine x times cosine x for this one, okay, over here we have cosine x. Now this cosine x, they cancel out each other, and now we have here limit as x approaches to p over 2 from the right side, and here we have 2 times 2, it's 4 times sine x. So this is equal to 4 times sine p over 2, it's 90 degrees, right? So it is sine 90. So we know that sine 90 is equal to 1. So this is 4 times 1, and this is equal to 4. In this question we have f of x is equal to 4 minus x when x is greater than or equal to 2. F of x is equal to x squared minus 2 when x is less than 2. So what is the value of limit as x approaches to 2 from the right side? F of x plus limit as x approaches to 1 from the left side, f of x plus 2. So in this kind of questions, for example, let's start with the first one. Okay, so here limit as x approaches 2 from the right side, okay, f of x. So this is actually, this means we can also write this as like this, right? So first we will start the first function. So when I get closer to x from the right side, which means that we will use the first function, right? Because here we have x is greater than 2. So when I do that, it means that 4 minus 2 from the right side, and this will give us 2 from the left side. Why? Because you get closer from the, let's say this is 2, okay, you get closer from the right side. So these values, they are greater than 2. So 4 minus these values, they will be equal to 2 from the left side, because these values will give us values less than 2. Okay, so after finding this one, you go and write here again f, the function of f of 2 from the left side. Okay, now I will use the other function because here x is less than 2, right? So now here we have x squared minus 2. So x squared minus 2. So instead of x, I will write 2. So 2 squared minus 2 squared is equal to 4 minus 2, and this is equal to 2. So as you can see, this is the value of our limit. So this first one is equal to 2. Now we will do the same thing for the second one. So here we get closer to 1 from the left side, but we don't have here x. We have x plus 2. So when I put 1 instead of x, this will be equal to f3, right? So 3 is greater than 2, so I will use the first one, which is equal to 4 minus 3. This is equal to 1, right? So now let me write here again. So f of x. So I find this one as 1, right? Because this one I use the first function, and that is equal to 1. Now I will do again for 1. So 1 is less than 2. Now I will use the second function. Okay. So here we have x squared minus 2. So instead of x, now I will write 1. So this is 1 minus 2. And this is equal to minus 1. So this is the answer for our second limit here. So this is equal to minus 1. So what was our question? So it is the sum of these two, and it is equal to 2 minus 1, and this is equal to 1. In this question we have limit as x approaches to infinity, square root of x squared plus 4x minus x. So when I put infinity instead of x here, I will get here infinity minus infinity. So what I should remember when we have this form of indeterminate, and also we have roots, when we have these two together, we will multiply and divide by its conjugate, right? So let's do that. So limit as x approaches to infinity. So I write this one, square root of x squared plus 4x minus x. So I multiply by its conjugate, which is equal to square root of x squared plus 4x plus x, okay, over, and I divide by its conjugate, which is equal to square root of x squared plus 4x plus x, okay. And this is equal to limit as x approaches to infinity. So this one, I can write this as x squared plus 4x minus x squared. Why? Because this comes from the difference of two squares, right? It is a minus b times a plus b is equal to a squared minus b squared, right? So it's over, we have its conjugate here. So this is equal to square root of x squared plus 4x. But how can I write this? I can take the highest exponent, right? So here we have x squared. So it's 1 plus, here we have 4x. So sorry, this is 4x, so I cannot write this 4x. This is equal to 4 over x. Sorry, yes, 4 over x. Because when you multiply x squared by 4 over x, it's equal to 4x. Okay, now and plus we have here x. Okay, now these x squared, they cancel out each other, and here we have limit as x approaches to infinity. So in the numerator we have 4x over here. This x squared, it goes out as x, right? So it's x square root of 1 plus 4 over x and plus x. And this is equal to limit as x approaches to infinity. So this is 4x over, when I take to x parentheses, it is square root of 1 plus 4 over x plus 1, right? Okay, now I cancel out these x's, and then from here 4 over x, when x goes to infinity, this is equal to 0, right? So in the denominator I have 4 over, in the numerator I have 4, in the denominator I have 1 plus 1, it's 2, so 4 over 2, 2 is the answer for our question. Now let's solve our last question. So here we have BC is perpendicular to AB and CAB is equal to x. So what is the value of limit as x approaches to 0, CD over BC? So it says that BC is perpendicular to AB, so which means here is 90 degrees, right? And we have here CAB, so we have here angle x, and its x limit as x approaches to 0, CD over BC. So let's say this CD is equal to A and this BC is equal to B. So limit as x approaches to 0, A over B is our question. Okay, so I know that here's 90 degrees, here we have x, and here will be 90 minus x, right? Okay. So from here, I cannot get anything. So let's draw this line to here. Why? Because I know that inscribed angles subtended by a diameter are right angle, right? So which makes here is equal to 90 degrees. So if this angle is equal to 90 degrees, also this one equal to 90 degrees, right? So here I have 90 degrees, I have 90 minus x, which makes here also equal to x, right? Now, I know that this angle is equal to x, and I have this right triangle here. I have my length A and B here. So let's look at our question. It asks limit as x goes to 0, A over B. Right? So here A over B, what this A over B is equal to. So in this triangle, A over B is equal to opposite side of angle x, okay, opposite side of angle x over hypotenuse, right? So this is equal to opposite over hypotenuse, this is sine, right? Sine function. And this is equal to sine x. You see? Now everything is much easier. Why? Because I know limit as x approaches to 0, sine x. So instead of A over B, I can write sine x, right? So all I need to do is to put this value instead of x. So this is equal to sine 0, and as you know, sine this line, right? So 0, it's here, so sine 0 is equal to 0.